customer is calling you guys out to do a clean and check because they want to make sure the equipment is going to prevent breaking down during the middle of the season. When it's at its coldest, they want to make sure that the equipment's going to be operating. They want to prolong the life of the equipment. They just put this equipment in, spend a good amount of money on it. They want to make sure it lasts as long as it possibly can. And then the last thing that maybe some customers don't talk about or don't always relay that they are wanting is the efficiency of the equipment. And out of those three things, the efficiency is one of the things that will impact, a clean and check will impact the most. If you do a proper clean and check, your efficiency will be the thing that is greatly affected, which then will fall in line with preventing breakdowns. Now, if you do a clean and check, can the furnace still break down when it's 20 degrees outside? Of course it can. There are some things that we can't foresee or see that's going to cause an issue, but there are lots of things that we can look at and tell, okay, this has a potential of failing, and that's when we can recommend a replacement of that component. We'll talk about that and go over these components here in a minute. And when do we do it? We do it at the just beginning of the season, just before they go to fire the unit off. Can they fire the unit off before a clean and check? Of course they can, but do it right just before the season or just before the heating or cooling season will take off. We're going to look at a 21-point checklist and then the main components of the system, and then do a restart, things like that. This is just a checklist. Right here is a 21-point checklist. Why a 21-point checklist? Because that's the very first one I looked at when I searched the internet for checklists. I mean, if you guys have a checklist, you guys can have a 10-point checklist, you can have a 99-point checklist. It really doesn't matter. Just some form of something to dock off or mark to know that, okay, I'm getting this completed, I'm getting that completed, and we're going to make sure we have a key couple of sections that we actually do look at and check. We're going to break it down into a couple sections, and the first section we're going to break it off into is the gas system. And we're going to check the burners, the pilot assembly, and then the flame sensor. Now this is a 21-point checklist. There's going to be some things on here that are obsolete and that you won't necessarily run into much anymore, which one of them is probably going to be a pilot assembly. Those tend to be mainly all replaced at this point in time. I'm sure you guys probably are still running into a few of them, but there's very far and few between. And if at any point in time you guys have any questions on what I'm going over, and if I'm running too fast, please stop me and slow me down or ask some questions. The questions are always great. The interaction is always fantastic to get to understand this a little bit more. So on your flame sensor, we're going to want to inspect that. Let me see. No. We're going to want to inspect the flame sensor. And you can take a reading on this and get an accurate reading off of this, and then clean it to see if your cleaning has been improved. A couple of ways to do this is to take the flame sensor and unhook it like they're doing right there, and you're going to read microamps. So you're going to need a meter that will read microamps. Above 1.5 is a good reading. Once you get 1.5 or below, you're going to start to get a rapid amber flash letting you know that you're getting a weak signal. Once it sees 0.1 or less, the flame will drop out. It will go into a soft lockout, and it will tell you either an 8 or a 9 flash, which is going to tell you, 7 or 8 flash, which is going to tell you a flame. 7 flash is flame wasn't present, an 8 flash is flame was present and then dropped out. So that's at 0.1 or less. At 1.5, you're going to get that rapid amber flash. So if you come up to a unit and you're seeing that rapid amber flash, you can definitely clean that flame sensor and see how well you improved it, see if it got up into the 3s or the upper 2s. At that point in time, if you'd like to leave that flame sensor, you can. Otherwise, it would be a good time and a suggestion to to offer that homeowner a new flame sensor. They're cheap enough, and that's a component that we don't want to have to come back after we did a clean and check when it's 20 degrees because we couldn't improve the reading or the rating on that flame sensor. A lot of control boards today, especially in the Texas Instrument control boards, and now White Rogers is also putting a flame current sensing pad on there. Most of the Coleman and Train units, Coleman and York units have the flame current sensing pad on them, so it makes it really easy for you to go up and take your leads and put it on there. That you're going to be checking volts DC. 1 volt DC equals 1 microamp, so you're going to get that same reading that you're going to look for, which is above 1.5 to 4, 3, 3.5, something like that. It's a good signal to see on a flame sensor. And how that flame sensor works is the control board is sending voltage out through the flame sensor. It does not work like a thermocouple where the flame hits it, heats it up, and the signal gets sent back to that flame, the wire that's from that flame sensor. That's not how it happens. There is voltage that's being sent out from that wire, and every board will do it a little different. Some boards do 120 volts, some do about 80 volts. It just depends, and that is AC. And then when the flame hits it, it rectifies it and goes to volts DC, and that's where the volts DC comes in play. Okay, that's when we'll see the change happen in AC to DC voltage, and it will rectify from the flame sensor through the flame, from the flame to the burner, from the burner to the manifold, and that's why we have that ground wire right there at one of the 4 bolts on the manifold. That ground wire will then travel back to that Molex plug, completing that circuit. That's why a 9 air code flash with reverse polarity or improper ground is so important, because we have to have that ground wire there to be able to complete that circuit. We cannot see any voltage on that ground wire. You guys run into the 9 air code flashes quite a bit at all? Anybody? Nobody? So you guys are lucky then, because that's something that we deal with a lot with 9 air code flashes with reverse polarity or proper ground. And to test that, you're going to go ahead and take the ground wire that's in the electrical panel box on the furnace that comes from the breaker box, unhook that, put your lead there, and then your other lead on your neutral, and that's coming in from the panel box and that's hooked up to the furnace, and you should see less than 0.5 volts. 0.5 volts or higher with an improper ground, and we have to have that taken care of back at the breaker box. I'm sorry?
I thought it was 0.2.
It's 0.4 is acceptable.
Okay.
0.4 or less. On your igniters, you're going to check the resistance of the igniter. Every igniter has a certain resistance at room temperature for it to be at. So you can take, and there's some charts out there for every different brand of equipment that you come upon, or any different brand of igniter that you walk up on. There is a different resistance between each one of those. I know Johnstone has some of the charts. You can find the charts online. Also, if you can't find them online, then give us a call. We'll get you that chart to you. But there's a chart that will say, thank you. There's a chart that will show you, for instance, this brand right here, this style, at room temperature will ohm out between 45 and 90 ohms. If it's over that, that is a good time to suggest or recommend to that homeowner an upgraded igniter. Now, these carbide igniters, they're going away. Most manufacturers these days are now putting silicone nitride igniters in there, which are a lot more durable, a lot more sturdier igniter. I highly recommend, anytime you come upon one of these that is bad, to replace it with a silicone nitride igniter. My favorite is the Hot Rod by White Rogers. It's a lot more versatile. It's a little bit longer. Sometimes the longer one does come into play, and it won't work on some of the 90% efficient furnaces. They're too long, but they also make a shorter one. Or you can use the Glowfly, but the Hot Rod has a much larger coverage. The mounting brackets they have in there will fit a lot more furnaces than what the Glowfly from Honeywell will do. And these are also a lot more durable. The silicone nitride igniters are a lot more durable than the carbide nitride igniters. I actually seen where they took a silicone nitride igniter and driven it into a piece of wood and turned it on, and then things still work. Now, I don't ever recommend doing that. But they are durable. They also tend to last a whole lot longer. Now, some myths on this one right here. The myth is do not touch the end of that igniter, because the oils from your hand will shorten the life of it. That is not true. That is a myth. Don't touch the end of it, because when it's glowing red hot, or glowing red, it's nice and hot and you'll burn yourself. And also don't touch the end of it because it's very fragile and it will break. And I don't know about you, but there's been lots of times on a Friday night at 4 o'clock, I go to put the thing in and I bump it up against the burner and it breaks on me. That's never fun, to try to scramble and find another one, and hopefully I've got another one on my truck, which usually I don't. So now I'm trying to figure out how I can grab another igniter and praying and crossing my fingers that Johnstone's going to be open. Check the igniter for resistance is something that you can do to prevent the breaking down. Next, we're going to check the gas pressure. This right here is one of the most important things that you can do during a clean and check. This is the thing that you're going to do that is going to mostly affect the efficiency of the equipment. Have you guys ever, has anybody in here ever used a combustion analyzer and know what the readings actually mean? Has anybody used a combustion analyzer? You have? Okay. And if you see on the combustion analyzer, what it will tell you is the efficiency of the equipment and what it's running at. And that's one of the things I like to do or like to talk about, is how a combustion analyzer can help retain or gain service contracts, if you guys use those. You get there and you'll check the efficiency of the equipment before you start. And we did this with one of the manager's houses. We checked the efficiency of the equipment before we started, and it was running under. It was an 80% efficient furnace, and it was only 6 years old, and it was running under 70% efficient. It was running at 68.5% or something like that efficiency. It was only 6 years old. So we checked the gas pressure. His gas pressure was really low. We increased the gas pressure back up to 3.5, and all of a sudden we've got the efficiency back to 80% on that equipment. So every year you need to check that gas pressure. Any gas valve that you install, I don't care if it's in a gas valve that's in a box this big, or if it's in a box that's 33 inches tall and 17 inches wide and has a furnace wrapped around it. 34% of every gas valve that gets installed is not calibrated properly. So if you install 5 furnaces in 1 week, or if you install 5 gas valves in 1 week, 2 of them are not set properly or set right. You need to adjust it. So on every install or every gas valve you install, or even one of the ones you walk up upon, you're going to want to check that gas pressure and get that back to 3.5 for natural gas and then 10 for LP. The minimum, the gas pressure coming into the gas valve, if you check your inlet gas pressure, needs to be at least 1 pound higher than what you're looking for. So for natural gas, it needs to be 4.5, and for LP, it needs to be 11. Because you're going to have about a drop across that gas valve as it's the gas is traveling through it. My favorite way to check for gas pressure is a dual port digital manometer. Up there is the UEI one. That's not a bad one. I like the dual port digital manometers because they do so much, and you're going to see a few things that they're going to be able to check for you and be able to test. One of them is gas pressure. Next, we're going to check for temperature rise. Temperature rise is another thing that's going to affect the life of the equipment and also the efficiency of the equipment. On every single manufacturer's data nameplate, where you can find the model number and serial number, they will have what the temperature rise is supposed to be for that equipment. And on average, you may see like 35 to 70 or 40 to 70 degrees. That's probably on average on most of them that you're going to run into. Some of them you'll see it lower than that. You'll see it 35 to 60. Some of them you'll see it, or I think there's one 35 to, or 25 to 55. And then on some of them you'll also see it a little bit higher. So don't just assume that when you walk up to this piece of equipment that all of them are going to be 35 to 70 like what you'll see on the majority of them, because every unit will be a little different. And you're going to want to take the temperature rise at the return. Okay, I don't care where it is on the return, somewhere in the return, take the temperature rise, or take the temperature, and then you're going to want to take it above the furnace. Now this one is very critical. This one you want to take at least 6 feet away from the heat exchanger so you don't get any radiant heat off of that heat exchanger and to affect the temperature that you're actually reading. So so if I gotta take it 6 feet away and I got an 8'4" basement, where do I gotta take that at? In the trunk line, yeah, about a foot and a half, 2 feet down from that trunk line is where I'm gonna wanna take that temperature. Now, if I'm running a little bit too heavy, if I'm running more towards the 70-degree mark, I'm gonna want to speed my blower up, okay? I'm gonna wanna increase my blower speed to get it more towards the middle of that range. The reason for that is because what happens when they give us a call to come out and do a clean and check? What do they do just before we get there? Change their filter, right? They change their filter just before we get there, and then you look over the corner and you'll see this thing that looks like a cat or a dog sitting over there, and it's the filter because it's been matted and in there since 6 months before you got there. So they're not changing their filter as often as they should. So if you're reading at that 70-degree mark, or close to that 70-degree mark, you're going to pretty much guarantee that once that filter has been in there for 2-3 months, that it's going to be pretty matted and not going to have the amount of airflow, and you're going to be above that. And that's going to trip that high limit in that furnace, and that high limit should never be replaced. If that high limit ever gets replaced, then we've got bigger issues that we need to be looking at. And airflow is definitely going to be that issue that we're going to look at. So check temperature rise. Now, if we're on the lower end of the thing, the scheme, so let's say if we're running 42 degrees across the heat exchanger or across the furnace, then we're going to want to, if that's what our temperature rise is, then we're going to want to slow our blower down. We're running too fast because the temperature of the air coming out probably is a little bit too cool, and we can increase that a little bit for that homeowner and make them feel a little bit more comfortable. But we want, again, the best target range, in my opinion, is going to be right in the middle of that 40 to 70 degrees or whatever we're looking at on that piece of equipment. Any questions on temperature rise? Next, we're going to go ahead and check the filter, like we just talked about. We're going to check the filter, make sure it's nice, clean, and clear. Check and clean the blower, motor, and wheel. If the filter has been out for a while, or you see a lot of dust and debris on the end of the blower motor, go ahead and clean it off so we can get good airflow across the motor itself. And then you're going to go ahead and check the inducer motor, making sure it's operating properly. Check the pressure switch. That's where that dual port digital manometer will come and play again, where you can check to see what the actual draft of that equipment is at, what the inducer motor is pulling. And what you'll do is you'll take a barbed T and 2 hoses, and your manometer is what will be needed. Now the UEI dual port digital manometer and the field piece manometer both come with the T's and the extra hoses that you'll need to do this check and this test with. And what you'll do is you'll take the hose off the inducer motor or off the pressure switch, either one, it doesn't matter, and you'll hook up your T and the 2 other hoses in line so you have your digital manometer there to be able to read what your inducer is pulling at. And if I'm supposed to be pulling at 0.65, that's what's on my pressure switch, I'm going to be pulling at least, I'm going to be pulling a lot higher than that on most cases. I shouldn't be really near that 0.65. I shouldn't be 0.68. I should be a lot higher than that. If I'm getting really close to that, then I'm going to want to start inspecting my flue to make sure that it's clean and clear. If I'm running it through a chimney, make sure that there's no debris in there. And of course, if I'm running it through a chimney, I better have a flue liner, so make sure that flue liner, if there's lots of bends and things like that in there, that can affect the pressure on that inducer. Making sure there's nothing blocking it. If it's a 90%er, make sure the same thing. Make sure there's nothing blocking it, that maybe there's no mud dauber nest or anything like that in the flue pipe. The 92% of every pressure switch that we can burn, that we fail, is actually good. 92% of them. How many of you guys have probably replaced pressure switches in here? Quite a few of you guys, right? So you're sitting there looking at me going, 92% of them, I replaced the pressure switch and it fixed the problem. Not necessarily. So what happens is when that pressure switch gets back to the factory, it works. And what happened, we did this one day, we had a pressure switch that came in out of the St. Peter's branch, it was on a Wednesday afternoon. And I took that pressure switch to show in my classes. I had a bunch of classes coming up where we were going to look at and talk about pressure switches. Friday morning, the pressure switch still showed bad. By Friday afternoon, was doing another class, and all of a sudden the pressure switch showed good. Well, what happened? It dried out. Moisture got inside that pressure switch. Okay? And moisture will get inside the pressure switch because of a couple of different reasons, and one of them is gas pressure. That's one of the leading reasons why it will get in there. If the gas pressure is running a little bit low, the flue gases will condensate and cause moisture to get inside the inducer and then that tube, getting that diaphragm wet, or there's actually a little tiny hole where that hose goes onto that pressure switch. If you look on the back side of there, there's a little tiny weep hole on there. And that weep hole is a bleed hole, because if you think about it, if I have a straw and I suck on that straw and I put my finger over the top of it, how long is that water going to be in that straw? Until I relieve some of that pressure, right? So that is what that weep hole is doing. It's small enough that when the inducer is on, it will close the diaphragm and the switch will close. But it's large enough that as soon as it shuts off, it allows the pressure to equalize, and debris and moisture will get inside that little tiny weep hole and not allow that pressure switch to function properly. So yes, 92% of the pressure switches that you replace are actually good. So should you wait 2.5 days and then come back with that same pressure switch? No, they're $14. Go ahead and replace that thing. They're cheap. And then at that point in time, you can figure out what caused that pressure switch to actually go bad. Inspect the heat exchanger for cracks. Now this right here is, there's a lot of different ways to check for a crack on your heat exchanger. And the best way is knowledge. The best way is to check for cracked heat exchanger is actually knowing where cracks actually occur and happen at. And every manufacturer and every heat exchanger that's out there have cracks in different places and in different spots. But for the most part, you'll be able to check for a cracked heat exchanger. The best place to look is going to be the furthest cell from the return, because that's going to be the hottest cell, and that's the cell that's most likely going to crack. And it's usually going to be around that first bend near the top, or where the metal is stressed the most or bent the most. That's going to be the most likely spot for most heat exchangers to crack. Another good indicator if you've got a cracked heat exchanger is going to be checking the static pressure of that system, or the airflow of the system. If you've got bad static pressure, which if anybody checks static pressure in here, you'll know that every one of our systems out there has bad static. We're typically running at a 0.8 to 1.2 or something like that, which is a double of what we're supposed to be running at, which is supposed to be at 0.5. You're checking your static pressure and you're seeing high static pressure, you're going to want to really start, especially if you're running it above the 0.8, you're going to want to start inspecting that heat exchanger, because that's going to be a good indicator that you're probably going to be able to find a crack in that system somewhere. Check the thermostat, make sure it's operating properly. You turn it up, the system comes on, you shut it, you turn it down, the system shuts off. Checking the heat anticipator. Again, this is the heat anticipator these days. That's on your own mechanical stats. Most of the stats don't apply that. They don't apply anymore on this list. And lubricating the motors that need to be lubricated with your oil. And again, adjusting your burners. That's not something you need to do, but I will suggest at this point, if you got the in-shop burners, making sure they're aligned properly and aren't misaligned, because what happens a lot of times if they become misaligned, the heat will build up inside that burner box, which will be one of the causes why the rollout switches will trip. Why are we talking about rollout switches? We just got finished talking about heat exchangers. Some myths that are out there with cracked heat exchangers, that if I get a crack in my heat exchanger, my pressure switch won't close. That is not true. And the other myth is that the rollout is tripping, it's a cracked heat exchanger. Again, that is not necessarily true. Can those two things trip and cause or show that there could be a crack in the heat exchanger? Yes, the pressure switch could potentially not open or close because of a crack. And yes, the rollout could trip because of a crack. But I've seen where there were 3/4 inch holes drilled on the back of each one of those cells on a heat exchanger, and the pressure switch closed and the rollouts never tripped. And carbon monoxide was being introduced into the room. So just because you have a crack in a heat exchanger does not mean that the pressure switch catch that, nor does it mean that the rollout will catch it as well. Again, checking your burners, inspecting them, making sure that there's no debris in the flame carryover channel, and making sure everything's aligned properly so that there's no delay when it travels from igniting from the igniter all the way over to the flame sensor. Checking your flue for obstructions. Again, this is checking with the pressure switch on checking the pressure switch with an inducer with a dual port digital manometer or a magnet helix will make sure and ensure that your flue is nice and clear and free from obstructions. And then checking the ignition sequence is proper, making sure again that there's no delay from the hot surface igniter all the way over to the flame sensor. Some tools that will be needed for a clean check: a good vacuum or shop vac to help to suck up any of the debris, a little brush to help clean the burners and knock off debris, and a little broom to sweep things up, some Zoom Spot oil to help lubricate the motors, shop towels, and AC Shine. Yes, AC Shine works great for cleaning the outside and shining the unit up. Let's face it, most everything up here, except for maybe the oil, doesn't really affect the performance of that equipment. Everything that's up here is really for eye candy for that customer. It's making that unit look nice and shiny, because for all intents and purposes, when they come and you do go over there for a clean and check, they're not looking inside that equipment to see or checking the equipment out to make sure that you adjusted the gas pressure. They're not looking to see if the flame sensor is now nice and clean and making sure it's going to be operating and not fail. What they look at when they go downstairs is oh, all the dust is off the top of the furnace and the door is nice and shiny. And they'll look at that, and that will resonate for the job that you had just done, and we're there for that cleaning. I also like to wipe down the water heater and keep the clothes away from the bottom of it so they can breathe a little bit better and not have issues for them there either. But wiping down the outside of that equipment is good to show that there was something actually done there besides just testing of the equipment, which again, that's what really matters, is testing of the equipment. I do like that UEI meter that's up there, the voltmeter. UEI, I used to not be a big fan of it. It used to stand for useless electronic instrument, but they've made some big changes in their meters, and that meter right there is the one that has a Bluetooth capability. And I always thought, okay, Bluetooth capability, when can these things be used as cameras again, right? I mean a phone, sorry. But when can, we use these things for everything except for what were intended for. Now all of our devices have Bluetooth capability or Bluetooth hookup to our phones. And I didn't necessarily see the benefit of having a meter hooked up to my phone until we were at a job and we were wanting to check the amp draw off the blower motor when it was running. Well, it's kind of hard to do with the door off. So that was one of the features that I was able to look at, was hook it up, leave the meter inside the unit, and close that door and see what the readings were happening with the door closed. They've come a long way in their tools, and that is a truly HVAC meter right there that can do just about anything that we're going to need or want for our systems and our equipment. Right below is the dual port digital manometer. Again, that's UEI's. UEI makes a great one that will come with everything that you're going to need to do for the UEI one and the field piece one both. We'll have everything that you're going to need to check for static pressure, check for gas pressure, and check for pressure switches. The field piece one I actually like a little bit more. It's about $30 to $40 more than the UEI one. The thing I like about the field piece is it comes with a pump on it. So you can, if you have a pressure switch that has failed on you or that's currently not reading properly because it's wet, you don't want to wait 2.5 days for it to dry out, then you can take a universal pressure switch, which I'm a big fan of, and you can turn the pump on and turn it up to 0.65 if that's what the pressure switch was at, and And then you can now dial that universal pressure switch to exactly 0.65, and there's leads on that field piece meter that will show you that that switch is closed, and then you know that you dialed that in exactly to the specs of the manufacturer. So it saves you from running all over the place trying to find the exact OEM replacement or something that will work. You have a universal one on your truck that will fix it. Like I said, there is a hole on the end of that pressure switch that if you want to take like stranded wire from a thermostat wire or something like that, and you'll see that hole. If you want to try to poke it in there to see if you can get the water bubble to burst out, or if you can see if there's any debris in there, go ahead and do that. Don't stick it in too far though, because you don't want to rupture the diaphragm, and you don't want to stick anything in there larger like a needle or a brooch that we would use to clean the burners. Don't do anything like that, because that will enlarge that hole, and then you'll have a harder time closing that diaphragm underneath certain circumstances. But using a scope is a good way to check for a cracked heat exchanger. Typically, we want the heat exchanger to warm up before we actually start looking at cracks. We want it to be running for about 10 to 15 minutes at least before we start inspecting for a crack on a heat exchanger visually like that. And a combustion analyzer, that's another great tool to use to check for a cracked heat exchanger. They're great because there's so many things that the combustion analyzer can do, and if you guys start using a combustion analyzer, it's going to set yourself apart from other companies that are out there, because hardly anybody is using a combustion analyzer out there. And what it's going to be able to do is one of the things we talked about before is check the efficiency of the equipment, so it can help to retain customers or gain new customers under these service contracts, where you can go there and say, your equipment was running at 68%. Once I left, I got it back up to 80%. And guys, we are all being exposed to carbon monoxide every single day inside of homes. And carbon monoxide will stay into your bloodstream and into your body for up to 7 or 8 years before the carbon monoxide that I'm exposed to today. It will take 7 or 8 years for it to leave my body. It stays in my bloodstream and my fat cells. We actually had a couple of contractors that were in one of my classes. We were talking about combustion analyzers and carbon monoxide, and they were exposed in a large industrial application. There was a boiler situation that was leaking carbon monoxide, and the doctors told them that they were not allowed to lose weight, because if they did, that all the carbon monoxide that was built up in their fat cells would release and potentially kill them. It's one of the leading causes of deaths in our industry that goes overlooked. We know a lot of guys maybe that have passed away from heart disease and whatnot, and the true underlying effect is actually being exposed to carbon monoxide. So having a personal CO detector on you at all times, in my opinion, is one of the safest things we can do in our industry to help protect ourselves. But this also will walk around and be used as a CO detector inside homes. And then you can also potentially look for cracked heat exchangers. Right now we're at 21% oxygen inside this room. It's actually 20.9% is what it actually is, what we call 21%. It's 20.9%. We stick that into a flue. We turn the furnace on. As the furnace heats up, it takes and burns the oxygen off, because that's what the fuel, that's what the flame needs, is 3 things: oxygen, heat, and ignition source. Oxygen, fuel, and ignition source. And as it's burning that oxygen, the oxygen levels will drop, and let's say it drops down to 9.2%. And then as if the blower kicks on, there is a crack in that heat exchanger, your oxygen levels will start to rise. And if your oxygen level rises when doing this test, then you can start to look further and see that a crack in the heat exchanger. Any questions, comments, concerns on cleaning checks? Excellent. All right, thank you very much.